Welcome to a new session of electrical engineering. In fact, basic electrical engineering we call this subject, which is introduced in JNTU first year syllabus. In fact, in first semester. Now, this syllabus is applicable to the sister allied courses of CSC background. Like if at all you have an engineering background of AIML or computer science with business system or computer science with design, computer science and cyber security, data science, and computer science with AIML. So for all these branches of engineering, this syllabus is common. Now you can see the list of the subjects which are placed for first year, first sem for sister and courses. In first subject, you have a matrices and calculus. This comes under mathematics. Then you have advanced engineering physics. Then you have programming for problem solving, that is C language. Then we have basic electrical engineering, and another subject you have engineering drawing, and corresponding labs are associated with these subjects. So overall you have total of 20 credits which is mentioned in JNTU syllabus. So let us go with actual syllabus of our interest, that is basic electrical engineering. The syllabus in unit 1 we have DC circuits, where you have electrical circuit elements like RLC, then you have voltage and current sources, and the basic applications of formulas or laws, that is KVL, KCL, mesh analysis and node analysis with DC excitation. Then you have some theorems like superposition theorem, Thevenin's theorem and Norton's theorem. And then we have time domain analysis of first order RL and RC circuit. In this session, we are not going to concentrate on time domain analysis of first order RL and RC circuits. The rest of the topics will cover here, and the rest topic, that is time domain analysis, we are going to see in the later session. Then followed by unit 2 you have AC circuits, unit 3 you have transformers, unit 4 you have electrical machines, and unit 5 you have electrical installations. Now especially we are coming across mid one, that is first mid for the engineering students. For that you have first 3 units. In that also we can complete half of the third unit, and that you can expect in mid one exam. So we'll start with the basic RLC parameters, which is nothing but resistor. As you know, it's a passive electrical component that opposes the flow of current. Then you have inductor, which stores energy in the form of magnetic field. Then you have the properties of inductor and the formula across inductor, which is given by these relations. Then you can come across the capacitor properties and the capacitor formulas. Then you have a source transformation. This is a current source. It can be transformed to a voltage source, or you can see an example here where we have transferred a voltage in series with resistor. It can be transferred to a current source in parallel with the same resistor. So this comes under source transformation. In general, we have only 2 types of sources, that is current source and voltage source. Then we have Kirchhoff's current law, which is defined as the algebraic sum of the currents at a particular node is equal to 0. For example, at this particular node, point A, if at all you apply KCL, you can easily get the value of current which is flowing in branch 5. You please comment in the chat box whether you are able to obtain the value of current in branch 5 or not. You consider this center point as node A. Then you have Kirchhoff's voltage law, where the algebraic sum of the voltages in a closed loop or circuit or mesh is equal to 0. Likewise, we have calculated the value of current which is flowing in this particular closed network. Here the current is obtained as 2 milliamperes. Again, you comment in the chat box whether you are able to get the same answer or not. Then we have the formula for resistors under series and parallel combinations. So if at all you want to calculate the voltage across resistor 1 or resistor 2, this is the formula. Similarly, current in parallel, you have the formula of I1 and I2. Then we can have the combinations of inductors and capacitors in series or in parallel combination. Inductor in series, you can obtain the value as L equivalent equal to L1 plus L2 plus L3. And for parallel combination, you can get the value of inductor, which is nothing but 1 by L equivalent is equal to 1 by L1 plus 1 by L2 plus 1 by L3. Likewise, you can calculate for 2 inductors or more than 2 inductors. And like inductors, in fact, unlike inductors, capacitor have the formula of 1 by C equivalent equal to 1 by C1 plus 1 by C2 for 2 capacitors placed in parallel. And for the in series, and for the parallel you have the calculation of capacitance, which is equal to C1 plus C2. Now if at all you go for the mesh analysis, here I have shown you a particular circuit where you can obtain the branch current and the loop currents, and using mesh analysis we are going to calculate all the requirements of ABC, and then we can apply the KVL to obtain the value of the loop currents. So here you can see we get the loop currents of I1, I2 and I3 as these values. Similarly, if at all you want to calculate the voltage or power calculations, the formulas are given and you can estimate the power value. And the same problem with the node analysis, by selecting node voltage V1 and V2 and applying KCL, you can get the values of current, which are quite similar to the voltage calculations or current calculations what we have done with the mesh analysis. Again, please comment in the chat box whether you are able to solve and get these values or not. Third is another current. We need to find out the value of branch current through 6 ohms. So the batch current of 6 ohms is obtained to be minus 0.231 amperes. So you can go through this particular PPT and you can comment in the chat box whether any mistakes are there or not, or you were able to calculate the values of voltages or current or not. Then we have a superposition theorem, which is definition is given over by this statement. Then how to obtain a particular solution using superposition theorem, for that I have mentioned the steps. Then an example is taken where you have two voltage sources and you need to calculate the value of voltage drop in 3.3 kilo ohms. So steps are repeated here as 1 and 2, and similar problems are done with the current sources, and 3 problems I have solved here for superposition theorem. And then you can go with the Thevenin's theorem. Again, a statement is given and the procedure is given. Then I have selected an example to obtain the VThevenin's and R resistance, and we are trying to find out the total current. You can apply mesh analysis, node analysis, and finally you can check whether you are able to get the same answer or not. Likewise, we got the value of current here as 1.043 for the given circuit. That is, for this circuit we got the value, that is the current in 10 kilo ohms we got here as 1.043 milliamperes. Apply mesh analysis or node analysis and check whether you got the same current or not. Then another example is given. We need to find out the value of current in 6 ohms, and the procedure is obtained using open circuit voltage and resistance, and then the power is also calculated for well behalf. And then we shifted our attention to the Norton's theorem. Again, Norton's theorem statement is given, and the procedure to solve a Norton's equivalent network for the given network, it is shown in problem 1 under Norton's theorem. And then Norton's current is obtained, and then the Norton's equivalent circuit is created, and this you can make quite familiar with the Thevenin's theorem with source transformation approach. Now like this you can solve n number of problems, and this particular session will give you quite knowledge of the syllabus and how the questions are framed, how you have to read about the theory, and how you have to prepare for the problems. For that I have created this particular video. That's all for today's class. I hope you like this particular session. Please share among your friends, subscribe to this channel and press bell icon for the future notifications. Thank you.